Good morning, dear students. My name is Ferhan Mazher, and today is the 5th of January, February, and it's 2022. Right now, I am with the ninth Cambridge class, and the subject we are studying is D Maths 4024. This is Cambridge O Levels Mathematics Syllabus D, and we are working on the syllabus. We are studying the D3 book, and this is New Syllabus Mathematics 7th edition, D3. We are working on the chapter number 10, and we have selected exercise 10B, and we will solve that exercise. This is the third lesson on the third video on this exercise. We have already done 2 videos on this exercise, in which we have done from question number 1 to question number 6. And today we will do question number 7 to question number 12 of this exercise, and hopefully this exercise will be completed. This exercise is about the arc length and the area of a sector. You remember the formula for the arc length is theta divided by 362 pi r, and the area of a sector is theta divided by 360 pi r square, where theta means the angle subtended by that sector at the center of the circle. So, and another very important thing is about the perimeter of the sector. We also find the perimeter of the sector, and we will learn how to play with this. So, without any delaying further, let's start this exercise. Okay, so the question number 7. We are going to solve question number 7. He says that the figure shows 2 sectors OAB and ODC with O as the common center. So here is that diagram. This diagram you can see. Here we have 2 sectors. This one is the small sector AOB, sorry, and the ODC is the big sector. Both of them have the same center. Both of them have the you can see they have different radius. The big one, the bigger one, ODC, its radius is capital R, and the small one, its radius is small r. So he says, given that OA is equals to r centimeter, OC is equals to capital R centimeter, and the angle AOP, the angle subtended by the sector at the center of the circle is M. Find the perimeter and the area of the shaded region OBCD. So this blue color shaded area, we have to find its perimeter and we have to find its area. The strategy is very simple. The perimeter means the outer boundary of this area, and that perimeter has an arc of the big circle, big sector, arc of the small sector, and this AD, which is a straight line, and BC, which is a straight line. AD and the BC both are capital R minus small r. And very easily we can find. And then if you want to find out the shaded area, the strategy is very simple. You see, we will find the area of the big circle, big sector. Then we will find the area of the small sector. And from the big sector, we will subtract the area of the small sector. And this is how you will find the area of this shaded region. So there are 3 parts: the value of the capital big radius, the value of the small radius, and the angle subtended at the center that they will be given. So all these 3 parts are exactly the same. We will do all of them. So in the first part, he says the small r is 10, the big R is 20, and the angle subtended at the center is 45. So let's do this. Okay. So here we go. So the radius, small radius is 10, the big radius is 20, the angle subtended at the center is 45. The AD will be equals to capital R minus small r, that will be 20 minus 10, and that will be 10 centimeter. BC will be capital R minus small r, and that will be 20 minus 10, and that will be equals to the 10 centimeter. The perimeter of the shaded region will be arc1 plus arc2 plus AD plus BC. So that is how you find the perimeter of that shaded region. So the arc one, that is the arc of the big sector. So that will be, the formula for the arc is theta divided by 362 pi r. So 45 divided by 360 multiply 2 multiply 5 multiply 20 plus arc number 2. That is the arc of the small sector. And that will be 45 divided by 362 pi multiply 10 plus 10 plus 10. That AB and the AD and the BC, they are 10, 10. So the answer will be 43.56, which will be 43.6 centimeters. So hopefully you understand how we found the parameter of this shaded region. Then we have to find the area of the shaded region. The area of the shaded region, the strategy is very simple. You will find the area of the big sector. From that, you subtract the area of the smaller sector. So area of the shaded region will be equal to the sector 1 minus the sector 2. The area of the sector, the formula is theta divided by 360 pi r square. So 45 divided by 360 multiply pi multiply 20 square minus the area of the smaller sector, and that will be 45 divided by 360 pi 10 square. So that will be 117.8, which will be approximately 118 centimeters square. So this is how you will do question number 7 and its first part. Hopefully you understand. In the second part, the strategy, the nature of the question, the story, the diagram, everything, the procedures, they are same. Only the values will change. The small r value this time is 5, the big R value is 8, and the angle at the center subtended by the sector is 120 degree. Let me show you. It's the same question. Okay. So the small r is 5 and the big R is 8, and the angle subtended at the center is 120. So the AD will be equals to 8 minus 5, and that will be 3. BC will be also capital R minus small r, 8 minus 5, and that will be 3. The parameter of the shaded region, there are two arcs, arc of the big sector plus arc of the small sector, plus there are two straight lines in the parameter, that is AB and the BC. So the arc 1 plus arc 2 plus AD plus BC. So the arc 1, the formula is theta by 360 2 pi r. So 120 divided by 360 plus 120 divided by 360 multiply 2 multiply pi multiply 8 plus 120 divided by 360 multiply 2 multiply pi multiply 5 plus 3 equals to, and that will be 33.2 centimeter. So this is how you will find the parameter of this shaded region. Now, then we have to find out the area of the shaded region. The strategy is very simple. Find the area of the big sector. From there, subtract the area of the small sector. The area of the sector is theta by 360 pi r square. So we will have 120 divided by 360 multiply pi multiply 8 square minus 120 divided by 360 multiply pi multiply 5 square, and that will be 40.8 centimeter square. So this is how you will find the parameter of this shaded region and the area of this shaded region. So that is question number 7 and its second part. Hopefully you understand. Question number, question number 7 and its third part. The small radius is 35 and the big radius is 49, and the angle subtended at the center is 160 degree. So if you want to find out the parameter of this shaded region with these values and the area of this region with these values. So that's the third part. So let's start. This is how we will do. So the small radius here is 35, the big radius here is 49. The angle subtended at the center is 160 degree. AD will be equal to the capital R minus the small r, and that will be the 49 minus 35, and that will be 14. Parameter of the shaded region is arc 1 plus arc 2 plus AD plus BC. Is the same procedure which we have done in the first part and the second part. So it will be 160 divided by 360 multiply 2 multiply pi multiply 49 plus 160 divided by 360 multiply 2 multiply pi multiply 35 plus 14 plus 14. So you will get 262.6 centimeter, which is approximately 263 centimeters. So this is how you will find the parameter of the shaded region. Then the question is find the area of the shaded region. That will be the big sector minus the area of the big sector minus the area of the small sector. So you know the area of the sector, the formula is theta by 362, pi r square. So we'll put the value. So we'll have 160 divided by 360 multiply pi multiply 49 square minus 160 divided by 360 multiply pi multiply 35 square. And that will give you 1642, which is approximately, when you round it off to three significant figures, it will be 1640 centimeter square. So we are done with the question number 3. Okay. I mean the third part of the question number 7. So this is question number 7 from the exercise. We are doing the exercise 10B from the book D3. So I'm done with the question number 7. So let's move to the next question. The question number 8 is coming up on your screen. It says in the figure, the area of the shaded sector POQ is 5 by 18 of the area of the whole circle. So find the angle POQ, and the B part is given that the area of the shaded sector is 385 centimeters square. Find the diameter of the circle. Okay, so this one is, I think, shaded because the shading is not clear, but this area is shaded. Okay, so let me show you my work. Question number 8. So it is given that the area of the sector divided by the area of the circle is equals to 5 by 18. And we know the area of the sector is theta divided by 360 pi r square, and the area of that circle is pi r square. So pi r square will be cancelled. So you are left with the theta by 360, and it is given that it is equals to 5 by 18. So cross multiply here. So you will have theta equals to 5 multiply 360 divided by 18, and theta will be equals to 5 multiply 20, and theta will be equals to 100 degrees. So the angle POQ, that will be 100. The angle POQ will be 100. Now in the B part, we have to find the area, we have to find the radius, and area of this sector is already given. So that is 385, and the angle subtended at the center by this sector is 100 degrees centigrade. So we want to find out the radius of this sector. You know the area of the sector, it is already given. It is 385 centimeter square. And we know that the area of the sector, the formula is theta by 360 pi r square. So we want to find out the value of the radius. So 100 divided by 360 multiply pi multiply r square. We want to find out the value of the r equals to 385. So when I will make the r square alone, so on the other side, it will be r square will be equals to 385 multiply 360 divided by 100 pi. So in your calculator, you will enter 385 multiply 360 divided by 100 pi equals to, and that will be 441.16. So approximately it is 441.1, or you can say 441.2 centimeter. And take the square root on both the sides, because this value was r square. When you take square on both the sides, you get r equals to 21. So the radius here of the sector is 21 centimeter. Then the actual question was, what is the diameter of this circle? So the diameter, you know, is 2 times the radius. So 2 multiply 21.0 or 21.2, or when you round it off, it is 21. So 2 multiply 21, that will be 42.2 centimeter. And that's approximately 42 centimeter. So this is how you will find the radius from the given information. Okay, so I hope that you understand this question. I have already checked the answers of this question with the book. They are good. Okay. So, but make it your habit to check the answers. Okay. So we are going to the next question from the exercise 10B. D3 is the book. Area of the sector and arc of the sector. During an art lesson, students are required to make a shape in the form of a sector of a circle of radius 12 centimeter. So the radius of that sector is 12 centimeter. If the parameter of the shape is 38 centimeter, It's in the form of a sector, so its perimeter is 38 centimeter. And you know the perimeter of the sector is radius plus the arc, and that's equals to 38 centimeter. Find the area of the paper used in making the shape. So we have to find out the area. So we know the radius of that sector, we know the perimeter of that sector. You know the perimeter is the radius plus the arc. So from there I can crack this question. Okay. So the question number 9, the perimeter is 38 centimeter of that sector. And we know the perimeter is radius plus arc, and that will be equals to 38. And the radius plus theta divided by 362 pi r equals to 38. And you know the r value is 12, so 12 plus theta by 360 multiply 2 multiply pi multiply 12 equals to 38. So that 12 plus 12 is 24. 24 will go on the other side and it will subtract. So you will have, when I will try to make 38 minus 24, and that will be 14. So I will take this theta. I want to find out the value of the theta. So I will take 2 pi and 12. That will be 24 pi. That is multiplying here. When it will go on the other side, it will divide. And the 360, which is dividing on the left side, when it will go to the other side, it will multiply. So theta will be equals to 14 multiply 360 divided by 24 pi, and that will be 66.8 degrees. 66.8 degrees. Okay. Now, if you want to find out the area of the sector, the formula is theta divided by 360 pi r square. The theta is 66.8 divided by 360 multiply pi multiply the radius is 12, so 12 square equals to, and that will be 84 centimeters square. So this is how you will do the question number 9. Okay, so we are going to the next question. The next question coming up on your screen is question number 10. He says the figure shows two circular discs of radii 11 centimeter and 7 centimeter touching each other at R and lying on a straight line PMQN. Show that the angle PAB is approximately 27.2 degrees. Hence, find the area of the shaded region. So we have to find out this shaded region. Okay. So the strategy of finding this area of the shaded region in this shape is very simple. You can see this is the trapezium. This is the trapezium. This side is 11, which is the radius also of the big circle. This is 7. This side is 7. It's the radius of the small circle. If we want to find out this shaded area, the strategy is find the area of this whole trapezium. From there, subtract the area of this sector, APR. Also subtract the area of this sector, BRQ, and you will have the area of this shaded region. So the strategy is very simple, and let me show you how this is done. So you can see the question number 10 is showing up on your screen. He says the figure shows two circular discs of radii 11 centimeter and 7 centimeter touching each other at R and lying on a straight line MPQN. So they are talking about this straight line MPQN. Here we have two circles. These two circles are touching each other. This big circle, circle A, whose center is A. This big small circle, whose center is B. At the point R, they are touching each other. And the radius of the big circle is 11 centimeter. The radius of the small circle is 7 centimeter. This radius is making 90-degree angle with this straight line. This radius here is making 90-degree angle with this straight line. This A to R will be also the radius of the big circle. So this will be 11. This R to B will be the radius of the small circle. So that will be 7. So this total length A to B will be 11 plus 7, and that will be 18 centimeters. So this shape is like a trapezium. whose this dimension is 11 centimeter, this dimension is 7 centimeter, and this dimension AB, that is 18 centimeter. Their question is show that the angle PAB, this angle at the point A, we have to find out this, and they say this will be 77.2 degree, and hence find the area of the shaded region. So we have to find out the shaded region, this shaded region. The strategy for finding the shaded region is we will find the area of this trapezium. You know the formula for the area of the trapezium is 1/2 into the height into sum of parallel sides, and then I will find the area of this sector, and I will find the area of this sector, and I will subtract the area of this sector and this sector from the area of the trapezium, and that will give me the shaded area. So I need to know this angle here, and then I need to know this angle here, because these angles are required in finding the area of the sectors. So let's see how I have done this. It's a little heavy question. Okay. So this question coming up your screen. So you can see that trapezium, which was showing in that diagram. I have drawn that trapezium here. So if this portion is 7, this portion will be also 7. I have drawn myself this XP line here. And this XP line is basically equals to the PQ line, that is the height of the trapezium. This is 7 and this is the 4. This will be 4 because this whole thing is 11. This angle is questioned. This triangle here, AXP, is a right angle triangle. So now I know this side is 4 and I know this is 18. I want to know this angle. It's a right angle triangle. So this will be my hypotenuse. If I'm going to find this angle, then this will be my base. You know the ratio of the base and the hypotenuse, that is called cos. So the cos of the PAB angle will be equals to the base by hypotenuse, and that will be 4 by 18. So angle PAB will be equals to cos inverse bracket start 4 divided 18 bracket close equals to. So that will be 77.2 degrees. So we have to show that is the first part. So now I know this angle, that is 77.2. This angle I already know is 90 degree. So the total angle here will be 90 plus 77.2. This angle here is this PAB angle is 77.2. Sorry, this angle is not 77.2. This angle is 77.2. I can find this angle. This angle will be 180 minus 90 minus 77.2. So let me show you. So the angle at the ABQ will be equals to 90 plus 180 inside the bracket. This is 180 minus 90 minus 77.2. So it will be 90 plus 12.8, and that will be 102.8. So basically what I have done, I have found this angle first, and then I have added 90 in it. So I got this angle, that is 102.8. So now I know that angle, I can apply the Pythagoras. I have applied the Pythagoras here on 4 and 18. 18 is the hypotenuse. This is the base. I will find this perpendicular by applying the Pythagoras, XP. So the BX will be equals to the under root 18 square minus 4 square, and that will be 17.55 centimeter. So once I know the BX value, the same values of the PQ. So area of the trapezium ABQP will be equals to 1/2 into the height of the trapezium. Height of the trapezium will be 17.55. And into the sum of the parallel sides, and one parallel side is 11, the other parallel side is 7. So when you enter these values in your calculator, you get the area of the trapezium 157.95 centimeter square. Then I will try to find out the shaded area. The shaded area will be from the area of the trapezium, subtract the area of the big sector and area of the small sector. I mean the area of the, let me show you. This strategy is basically this. We will find the area of this whole trapezium. From that, I will subtract the area of this sector, and I will subtract the area of this sector. So that is the strategy. Okay, so we will have area 1 minus sector 1 minus sector 2. So it will be 157.95 minus the sector 1 at angle at the center is 77.2 and its radius is 11. So it will be 77.2 divided by 360 multiply pi multiply 11 square minus the area of the sector number 2, which is the sector of the small square, a small circle. That will be 102 divided 102.8 divided by 360 multiply pi multiply 7 square equals to, and that the final answer will be 32.5 centimeters square. And this question is little tricky, but I hope that you understand this question. So let's go to the next question. The next question is question number 11. Okay, so let me show you. Okay, so the next question coming up on your screen is question number 11. He says, two circular discs of radii 4p centimeter and p centimeter touch each other externally and lie on a straight line AB as shown. Find an expression in terms of p for the area enclosed by the two discs and the line AB. Okay, so we have to find out the area of this or area of this thing. And this big circle, its radius is 4p. This small circle, its radius is a p centimeter. It's exactly the same question as the question number 10. We have to find out the area of this shaded region. So let's see how I have done this. So here we go. So I have taken that trapezium, and this is the center of the big circle. This is the center of the small circle. This is that straight line. And this radius is P. This big radius is 4P. This portion will be P. So this portion will be 3P. Here the two radius are touching each other. So this will be 4P plus P, and that will be 5P. So this dimension is 5P. This dimension is 3P. I have drawn this line myself. Let me call this angle theta, this angle as phi, this is 90. So I will apply the cos theta. The cos theta will be equals to the base by the hypotenuse. The base here is 3p and the hypotenuse here is 5p. So p and p cancel. So theta is equals to cos inverse bracket 3 divided 5 bracket close equals to, and that will be 53.1. So this angle theta here is 53.1. Now I can find the angle phi. The angle phi will be equals to, because this is a triangle, so it will be, angle phi will be equals to 180 minus 90 minus 53.1, and that will be equals to 36.9. So the area, now I know this angle, so the area of the sector will be, I will use this angle for the big sector. I will use this whole angle for the small sector. Its angle will be phi plus 90 degree. So the area of the trapezium is equals to, 1 by 2 into height into sum of parallel sides. So the area of the trapezium will be this side. But I need to know, first of all, this side. I want to find out how much is this. Okay, so I will apply the Pythagoras on this right angle triangle. It will be 4p square equals to 3p square plus xy. This line is xy. I want to find out this in terms of p. So it will be 25p square equals to 9p square plus xy whole square. So xy whole square will be equals to 9p square, 25p square minus 9 square, 9p square. That will be 16p square. Then I will take square root on both the sides. So you will have 4p. So xy will be equals to 4p. So I know this side 4p, this side is also 4p. Now area of the trapezium, I can find out that is 1 by 2 into height into sum of parallel side. So I can find that that area 1 by 2 into 4p plus p. And this 4p and 5p, that will be 20p square divided by 2, it will be 10p square. So the area of that whole trapezium, which I have shown you, is 10p squares. Then I will find the area of the big sector in the circle A, and I will find the small sector, small circle sector. Let me call it the sector number 2. So the area of the sector number 1 will be 53.1 divided by 360 pi into the radius square. That will be 4p square, and it will be, when you enter these values in your calculator, you get 7.41 p square. Area of that other sector, which was in the small circle, that will be its angle at the center is 126.9 divided by 360 multiply pi multiply p square. You will have 1.11 p square. So from the area of the trapezium, subtract the area of the sector 1 and area of the sector 2. So you will have A1 minus A2 minus A3, and that will be 10p square minus 7.41 p square minus 1.11 p square, and that will be equals to 1.48 p square. Okay, so this is how you do this question. Hopefully you understand. These questions are little difficult for question for the class 9, but if you try, you will be able to understand. So that was the question number 12. Okay, so now we have question number 12 coming up on your screen. So the question number 12 coming up on your screen. He says, in the figure, O is the center of a circle with the radius 16 centimeter. PYB is the minor arc of a circle center A and the radius 32 centimeter. OX divides the triangle OAQ into two congruent triangles. So this OX is basically dividing this triangle OAQ into two equal triangles. Given that the angle OAQ, so this angle is 66, find the angle BOQ, the angle BOQ. You can see this is radius, so if this is 66, this will be also 66. So from 180, I will subtract 66 and 66. So you will get this angle, and once I know this angle here, QOA, then I can find this angle, that will be 180 minus whatever is the angle here. Or you can say this angle will be equal to the sum of these two angles. You might have studied this in D1, that the external angle of the triangle is equal to the sum of the opposite internal angles of the triangle. Okay, so let me show you how I have done this, the first part, and let's start. So the question number 1 is coming up on your screen. He says BOQ is question mark. The BOQ angle will be equals to the 66 plus 66, and that will be 132. External angle of a triangle is equals to the sum of the opposite internal angles of the triangle. So you will have 66 plus 66, that will be 132. So once I know the BOQ angle, then the second part is the second part of the question is, they want you to find out what is the length of the AQ. The length of the AQ, this length they want. So because this line has bisected, it's an isotriangle. So this AQ has been divided into two equal parts. So I will find out first the AX only, and from there I can so you can see this is so this is 16, this is 16, they both are radius. So it's an isotriangle. So this OX line, which is making 90 degree here, will bisect this AQ line. So I will find AX and then I will double it, and that will be AQ. So this is a right angle triangle. Here I know this angle and I know this is the hypotenuse, and I want to know how much is this AX, which is the base. So I will use the cos 66 is equals to the base by hypotenuse, AX divided by 16. So the AX is equals to 16 multiply cos 66. So that will give you 6.5. So from A to X, the length is 6.51. You double it. So then you get AQ, that will be 2 into 6.51, and that will be 13.0 centimeter. So this is how you will find the AQ. So that's the second part, and let's check what is the. Okay, so let's see what's the next part. He says the parameter of the shaded region. So if you want to find out this, the parameter of this shaded region, the parameter of the shaded region has this arc. This is the arc of this sector here. I know this angle here, BOQ. I know its radius is 16. Then the parameter also includes this arc, which is the arc PYB, and its radius is 32. The angle, its center is at A, and the angle at the center is 66. So you know you can find this arc, you can find this arc. This is a straight line. This whole thing, A to P is 32. From A to Q we have just found. So from A to P I will subtract AQ, you will get the QP value, and then you will add these two arcs and this straight line QP, and that will give you the parameter of the shaded region. So this is the strategy on which we will work. So let me show you. So the parameter of the shaded region, first of all, I will try to find out the QP. The QP side will be equals to AP minus AQ, and that will be 32 minus 13, and that will be 19 centimeter. That straight line QP is included in the parameter. Then I will find the arc 1, and the arc 1 is the big arc whose center is at A, and its radius is 32, and the angle subtended at the center A by this arc is 66. The formula for the arc is theta divided by 360 2 pi r. So 66 divided by 360 multiply 2 multiply pi multiply 32, and that will give you 36.9 centimeter. The arc number 2, the area, we have to find out the length of the arc number 2, and the angle subtended at the center by the that second arc is 132, and the radius is 16. So the formula for the arc number 2 will be 132 divided by 360 multiply 2 multiply pi multiply radius, that's 16. So that will give you 36.9 centimeter. The parameter will be the QP straight line plus the arc 1 plus the arc 2. So it will be 19 plus 36.9 plus 36.9. So that will be 92.8 centimeter. So this is how you will find the parameter of that shaded region. Now at the end, the question is the area of the shaded region. So we want to find out the area of this shaded region. You can see I will find the area of this whole sector. Then I will find the area of this sector, and I will find the area of this triangle. From this big sector, I will subtract the area of this sector and this triangle. So I will get the area of this shaded region. So let me show you my strategy. So the shaded area will be sector 1 minus sector 2 minus the triangle OAQ. The sector 1 is 66 divided by 360 pi 32 square, minus sector 2 will be 132 divided by 360 pi multiply 16 square, minus the area of that triangle will be 1 by 2 into 16 into 16 into the sine of 48. So you will have 294.9 minus 95.1, and that will be 199.77, which is approximately 200 centimeter square. So that was the question number 12, and its fourth part. So, my dear students, question number 13 of the exercise 10B. In the introduction of this video, I told you we will be solving up to question number 12, but we have now I have arranged the question number 13 also. So I am including that question in this video also. That's the last question of that exercise 10B. The figure shows a quadrant of a circle of radius 12 centimeter. Given that B is the midpoint of the arc AC, find the length of the BD. So this is the arc of the quadrant. The word quadrant means the fourth portion of a circle. So this arc is 1 by 4 of the arc of the circle. This is 1 by 4th arc of the full circle. So I can find the arc of the full circle, that is 2 pi r, and I will divide it with the 4. I will get this ABC arc. Then the BC arc will be half of the ABC arc. And then I will join this point here, and I know this arc, and I know the radius is 12. I will be able to find out the angle subtended here. So once I know the angle here, I know this will be equals to 12 because this will be also radius. I know this angle very easily. I will be able to find out this BD, which will be like perpendicular to that in that right angle triangle. So this is the strategy for the first portion. So let's solve it. Okay, so there we go. So here is that diagram. I hope you can see it clearly. This is the quadrant. Quadrant means the angle here is 90, and this is 1/4 portion of a circle. So I know this radius. I will find the arc ABC. The arc AC will be 2 pi r, which is full circle, divided by 4 for the quadrant. So it will be 2 pi multiplied divided by 4, and that will be 18.85. The arc BC will be half of the 18.85, and that will be 9.4 centimeter. The arcs CB, that's the arc of the sector, this sector, BCO, and I will try to find out this angle at the center. So I know the arc length, I know the radius, so very easily the formula for the arc is theta divided by 362 pi r, and I know the arc already, that's 9.4. So theta divided by 360 multiply 2 multiply pi multiply 12, that will be equal to 9.4. So if I make theta the subject of the formula, it will be 9.4 multiply 360 divided by 24 pi equals to, and that will be 44.9. Whatever I'm saying, you type it in your calculator, you will get the same answer. So you will, in your calculator, you will write 9.4 multiply 360 divided 24 pi equal, and you will get 44.9 degree. So this angle here is 44.9, which is approximately 45 degree. Now it's a right angle triangle. You can see that this triangle is a right angle triangle. And this is the radius, and it will be 12. And I know this angle, that's 44.9, approximately 45. So I can find out this PD, that is the perpendicular for this triangle, a right angle triangle ODB. So I can apply sine 44.9, that will be equals to the perpendicular divided by the hypotenuse, that will be BD divided by 12. So BD is equals to 12 multiply sine 44.9 equals to, and that will be 8.5. So the length of the BD will be, this BD line will be 8.5 centimeters. So I hope you understand how this is done. Okay, so let me show you the next part of this question. And next part is find the perimeter of the shaded region. We have to find out the perimeter of this shaded region. The perimeter of this shaded region is the arc BC. We already know this arc BC. We have this straight line BD. We already have calculated in the first part. I want to know what is this CD. You know, this whole thing is the 12 centimeter. By using that right angle triangle, I will find the length DO. And from the CO, I will subtract the DO, and that will give me the CD. So that's the strategy. So then I will add this, this, and this, and that will be the parameter of the shaded region. So let me show you. So I will apply on that right angle triangle, on this right angle triangle. I know this is 44.9. I know this is 12. I want to know DO. I will apply the cos. Cos will be the base by hypotenuse. So I will get the value of the DO. Okay, so here you can see cos 44.9 equals to the OD base divided by hypotenuse. That's 12. So OD will be equals to the 12 multiply cos 44.9, and OD will be 8.5. Once you know the OD, CD will be, what is CD? CD is this thing. CD. I want to know the CD. This OC or CO is 12. I know the OD, that is 8. I think how much? 8.5. Yeah. 8.5. So 12 minus 8.5, you will get the CD. Let me show you that process. CD is equals to CO minus DO, and that will be 12 minus 8.5, and that will be 3.5 centimeter. So the arc is, we already have calculated. I just showed it again here, how you found that arc. 44.9 divided by 360, multiply 2, multiply 5, multiply 12, that will be 9.4. The perimeter of the shaded region will be, there are two straight lines and one arc, and that will be 9.4 plus 3.5 plus 8.5. So it will be 21.4 centimeter. Okay, so next question is third part. Let me first of all show you the question. He says, find the area of the shaded region. The strategy is very simple. You know, we have drawn a line here. I'll find the area of this sector, and from this area of the sector, I'll subtract the area of this right angle triangle ODB. So that the remaining will be the shaded area. Okay, so the shaded area, question number 13 is third part. Area of the shaded region will be area of the sector. The formula for the angle subtended by the sector is at the center is 44.9 divided by 360 pi 12 square equals to 56.42. Let me call it A2. Area of the triangle ODB will be 1/2 into base into height, and 1/2 into the base is the height is BD and the base is OD. And 1/2 into 8.5 into 8.5, and that will be 36.13 centimeters square. Let me call it A1. The shaded area will be the area of the sector minus the area of that triangle, and A2 minus A1, and that will be 56.42 minus 36.13, and that will be 20.29 centimeters square. So, my dear students, we are done with this question. So we are done with this exercise. So let me correct this one. It's question number 13. We are done with up to question number 13. Okay. So today we have done exercise 10B from the book D3. The name of the book is New Syllabus Mathematics 7th edition. This is Cambridge O-Levels Mathematics Syllabus D, and we are working on the chapter number 10. Today we have completed the exercise 10B. Today in this video, in this session, we have completed from question number 7 to question number 13. We have already done 2 videos on this exercise. In the first video, we have done from question number, we have done only question number 1 in that video. In the second video, we have done from question number 2 to question number 6, and this was the third video, and we have completed this exercise 10B. I have tried my best to explain you the concepts. You will actually learn mathematics when you do it yourself. And the teacher can only help you a little bit. The teacher can make the things a little bit easier for you, but you will actually learn when you will do it yourself. I hope that this video will be helpful to you. If you think that this video has helped you, it has made your life a little easier, don't forget to subscribe my channel, like this video also, and share the link of this video with your class fellows, with your cousins, with other students who are in the 9th Cambridge, who are in the 10th Cambridge, who are in the 11th Cambridge. These videos can help you. They can also help them. It's a great blessing for me to be with you online and teach you online. So keep supporting my channel, and I will keep working on the videos. So thank you very much, everybody, and God bless you all. Have a good day.